Nice. Good to meet you all. Right now, I'm doing an all about servers. Um, I've been learning about servers recently for some reasons, and I want to share my knowledge. And I think it'd be fun to do a video. So that's what this is. Um, First of all, my name is Ruchir. You can also call me Ruchi. Okay, cool. Let's get into it. We're gonna start with DDR5 SDRAM. Okay, so people say RAM. RAM is random access memory, but RAM is not RAM. RAM today means DDR5 SDRAM. Okay, so let's break this down. DDR5 SDRAM. Uh, this is a long acronym. There's a bunch of letters here, some numbers even. Let's figure it out. So this is a double data rate, 5th generation, synchronous dynamic random access memory. Okay, this is an IC. This is a chip. IC meaning a integrated circuit. So this is one of those things. When you break open your phone, you see a bunch of um, crazy looking shit, some square shit with some leads going out of it. It's on a board. It's on a circuit board. That's what this guy is. A chip. It's a memory chip. Okay, so what is a double data rate 5th generation? That is a type of SDRAM, and it's the 5th generation double data rate SDRAM. And then what is the S&D part? Well, synchronous and dynamic. There is no RAM today used that's not synchronous or dynamic. So when people say RAM, they mean SDRAM these days. Okay, it's all confusing now. Um, I think it's because old people like 20, 30 years ago, everyone was using the word RAM, and then stuff evolved so quickly, right? And people got used to saying the word RAM, so just never stopped using RAM. But they really just started meaning this stuff. Okay, so that's it for DDR5 SDRAM. Yeah, it's used for high speed memory and servers. Okay, we'll talk about um, the DIMM that it goes on to, also known as a RAM stick, later. Now we're going to talk about PCIe. Okay, PCIe. This is the Peripheral Component Interconnect Express. Okay, what is it? It is an interface. It's a high-speed interface standard for connecting peripherals like GPUs and such to the CPU. GPUs and like expansion cards to the CPU. So you've got all these PCI slots on your motherboard, right? A great way to learn about servers is just look at the motherboard and look at all the connectors and look at what goes on to those connectors, right? So you got your PCI slots, and those are like you got your motherboard, and they look like kind of like this. And the PCIe like specifications is all, even the traces that go in the board. It's all those traces, and it's also it's also like a standard for like communicating over those traces, over those it's a routing layout and the physical layout, etc., and also like the way to communicate between them. CPU to peripherals like GPUs and storage devices. So some examples of like expansion cards. So like people say GPUs and graphics cards and they mean the same thing, but they don't mean the same thing. Graphics cards are actually different from GPUs. GPUs go onto graphics cards. GPUs are ICs. Graphics cards are PCBs, printed circuit boards, that have the chips. Chips and ICs are like interchangeable. So graphics cards are the PCBs that have the chips on them, and they've got like the chips, and maybe they've got some extra stuff like, I don't know, power controllers or whatever, chips as well on the PCB, which connect onto the PCIe slot, the expansion slot. And other expansion cards include network interface cards. Um, Blanking on some other ones, but there's a bunch of cards that you can put in. Everything in a motherboard is modularized, so you can take cards out and replace them. This is because things in tech evolve so quickly. Imagine you build $1 billion data center, and everything is like soldered on. Wouldn't that suck when the next generation comes out? So that's PCIe. Okay, So now we're going to talk about NVMe. Okay, NVMe. This is the non-volatile memory express. Okay, NVMe is a protocol over PCIe. Okay, so PCIe is a physical layout. It's all these specs, and then NVMe is a protocol for high-speed memory data transfer, specifically to SSDs. We'll talk about what SSDs are. Those are solid-state drives, and NVMe SSDs. So NVMe is a protocol. Notice like DDR5 SDRAM, NVMe SSDs. DDR5 is like the protocol kind of for like communicating, and then SDRAM is like the thing, and then NVMe SSDs. NVMe is like the protocol for communicating. SSD is like the thing, so it's kind of communicated like that. But in general, NVMe SSDs it's a protocol for accessing high speed storage devices like SSDs over a PCIe interface. So NVMe is a methodology for using PCIe. You should look at about that. It's a protocol for the PCIe interface. So it's a methodology for using PCIe. To read and write memory to SSDs. Okay, nice. Let's talk about InfiniBand. InfiniBand is so we were talking about like interfaces and protocols for communicating between components and chips and such on the motherboard. So these are like chips and communicating over traces. Now we're going to talk about InfiniBand, which is a totally different thing. It's not at all chips that are talking to each other. It's in fact servers talking to servers and servers talking to storage. It's actually wired technology. It occurs over it's communication technology that is like over fiber optic cables or copper cables. So let's talk about that right now. InfiniBand. Previously, the IP for InfiniBand was owned by Mellanox, and Mellanox was a monopoly on InfiniBand. And then NVIDIA bought Mellanox, and now NVIDIA owns the InfiniBand IP. So fun fact for you there. It's high performance networking technology, and it's used for it's a data center interconnects, high speed communication between systems, server to server, within a data center or HPC cluster. Data center HPC meaning a high performance computing cluster. It's a wired technology that typically uses fiber optics and copper cables. Yeah, so it's not just a protocol. There's a physical definition. There's like packet formation definitions, everything. That's what InfiniBand is. It's a whole interface stack. Okay. Now let's talk about memory devices. For memory devices, right, we're going to talk about HDDs. So we're going to start with that. HDDs. So we're actually going to rank them. All right. We're going to rank them. HDDs. Okay. And then we're going to talk about SSDs underneath that. And then we're going to talk about DIMMs. DIMMs. Okay, let's do it. Let me first verify that I am not stupid. I really hope I'm not, but I totally could be. Oh my god, it might in fact be the case that I'm stupid. I really hope this is not the case, but we'll check so we can figure it out, you know? Looking for I'm looking for my latencies. Aha! I'm not stupid. Perfect. Okay, HDDs are hard disk drives. Okay, these guys have millisecond latency. Okay, millisecond, 1,000th of a second. All right, so let's look right here. I should pressing harder, way more visible. Millisecond latency. Okay, 1,000th of a second. SSDs, and these are non-volatile. Turn them off, and the memory stays. So whatever's memorized by the HDDs. Basically, it's actually interesting technology. So it's like a spinning disk. It spins at 15,000 RPM, and it's got like a magnetic coating over it. And then there's like there's an actuator. So like imagine like a record label, not a record label, like a record. What's a record machine called? Record machine. So put one of those records on the record machine. You know the head that goes on top of it and writes and also reads, like it, like puts the grooves on, reads the grooves. There's something like that, an analog, an actuator for HDDs. It like writes magnetic information, but this thing is spinning at 15,000 RPM. It's writing it into the magnetic thing. It's like encoding it into like the magnetically. Fucking pretty insane. People are insane. Um, Yeah, so it's a traditional storage device. It's been there for a lot. It's cheap. It's super cheap. It's for bulk storage. It's high latency, millisecond. So yeah, it read writes with a turntable like ARM. Now SSDs, okay, SSDs are microsecond latency. Microsecond latency. That's much faster, right? That's a maybe 3 orders of magnitude faster. I think so. I think it's 10 to -6, -6. This is 10 to -3. So yes, 3 orders of magnitude faster. 3 orders of magnitude. It's 1,000 times faster. Um, it's a way faster alternative to HDDs. It uses flash memory, so it's non-volatile. It stores data when the power is off. So HDDs and SSDs are both non-volatile. Okay, I'm gonna put NV. This guys are NV. And now because these guys are NV, right? You probably are assuming this guy's V. Yes, this guy is a volatile memory. But DIMMs are super fast, man. But let's talk about SSDs. SSDs are solid state drives. Okay, so they're what that basically means is they're solid state. They're like literally solid. Um, yeah, and it's flash memory. So like I forgot how flash works. Maybe I'll talk about it later. Microsecond, and this is millisecond. Okay, now DIMMs. Okay, DIMMs are dual inline memory modules. Okay, what these are. So now when people say DIMMs, okay, I'm gonna talk about this later. But when people say DIMMs, they really mean something else. But I'm gonna talk about that. The way that RAM means SD RAM, DIMMs means something else. Um. Okay. Anyways, dual inline memory modules. These are RAM sticks. These are nanosecond latency. My God, this is 1,000 times faster than even the SSDs. Yes, they communicate with the CPU over a separate memory bus, not PCIe. They are super incredible. There's so much to talk about with them. Basically, DDR5 SDRAMs are individual IC, individual chips that get assembled onto a larger circuit board called a DIMM, called a dual inline memory module. Okay, and that is the primary data storage memory solution. Okay. Um, it expands RAM capacity. It's basically just a PCB with like 8 to 20 DDR5 SDRAM chips, and it's got a power management IC or something, a PMIC. It's the best solution for a server's primary working memory. Working memory. Okay, so it's working. What that means is not like not non-working. Okay, like SSDs or maybe HDDs, right? Not non-working. It's like working memory. Like I've got my workload. I'm an AI. I'm a GPU. I'm an AI GPU. I've got my workload. This is my working memory. This is my training data for like right now. Um, Anyways, these are also called RAM sticks colloquially, and they plug directly onto special RAM slots on the motherboard, not expansion cards, not PCIe slots. And those RAM slots speak DDR protocol. DDR protocol, baby. Current standard is DDR5 RDIMMs, but the next evolution, state of the art, SOTA, is DDR5 MRDIMMs. Okay, so what are we talking about, guys? We are talking about MRDIMMs. Okay, DDR5 MRDIMMs, DDR5 SDRAM MRDIMMs. Okay, maybe even ECC DDR5 SDRAM MRDIMMs. Okay, that sounds like a bunch of acronyms, bunch of letters. But listen, like there are no DIMMs anymore. People don't use DIMMs. Okay, they use RDIMMs. Okay, registered dual inline memory modules. Wait, that is what R means, right? I really hope that's what R means. Oh God, that is not what it means. Rank. It means rank, or maybe it means registered. Um. Okay, it might mean ranked. It might be ranked or it might be registered. You guys should probably check that out. Don't take my word for it. But anyways, RDIMMs are what people are using right now, right? But MRDIMMs are like the next generation, okay? Even bigger than RDIMMs, they've got MRDIMMs, all right? And multiplexed rank dual inline memory modules, all right? It's hype. It's the next generation. It's the latest and greatest. Um, yeah. Let's talk about more stuff. Let's talk about CXL, Compute Express Line. So this is all memory, right? Great memory stuff. Now you know DIMMs are the working memory, volatile. They go on. They are RAM sticks, colloquially. They go onto the RAM slots on a motherboard, and they are super hype. They've got their own memory bus that connects to the CPU, and they talk DDR protocol. And SSDs got NVMe over PCIe, and HDDs, who fucking knows? Those guys are old dinosaur. CXL, Compute Express Line. CXL. Bang bang. CXL, high speed interconnect for CPUs, okay? Namely, CPUs, memory, and accelerators. This is for memory sharing. This is for caching. This is for, what's it called? Coherence. Cache coherence. So important. Let's write it down, okay? Cache coherence. Yes, this bad boy is for cache coherence. Everybody needs to know the same memory. Everybody needs to treat memory like like it's memory. People can't treat different memories like different memories. Okay, they can't be like an updated memory and people not know about it. Okay, everybody's got to know about it. Cache coherence. This is cache coherence. Uh, Now this is interesting. It's not just a protocol, CXL. Okay, it's a full interconnect architecture on top of PCIe. So why is everything on top of PCIe? I don't know. Good question. I'll probably I asked that myself. I asked it like to like other people to myself. But yeah, everything's on top of PCIe. Isn't that crazy? But it's a high-speed interconnect for memory sharing between and pooling with cache coherence between CPUs, accelerators, and memory, obviously. But accelerators is interesting. Okay, so what are accelerators, right? I just want to talk about this for a second. Accelerators are specialized hardware. Okay, specialized hardware like FPGAs or ASICs that connect to the host CPU and accelerate specific tasks by offloading computation. Okay, now does that sound familiar? Accelerating specific tasks by offloading computation. Can you think of a really important, super cool accelerator these days that everyone's talking about? GPUs. GPUs are nothing but an ASIC. There used to be an ASIC just for graphic processing, and now they're an ASIC or an accelerator just for the specific task of offloading computation off the CPU for AI workloads. Why is that the case? Because CPUs are really good at sequential processing, banging out really hard tasks one at a time. Like if you had some guy do long division multiple times, that's a really hard task. And if you had to do them like one at a time, they'd like that then the CPU would be really good at that, really good at that. But if they do like a lot of super small tasks, like addition or multiplication, at the same time, then a GPU would be really good at that. Okay, CPU hard tasks one at a time. GPU not hard tasks, but many at a time. I'm getting a call from my brother. Okay, let's put this guy on the speaker. What's going on, Roshan? Oh, I didn't make the food. Instead, I made tuna salad sandwiches and made two of them, and I ate them. I'll make the little cheesy bread thing later. I don't know, bro. I'll let you know. I'm in the middle of something. Okay, I'll call you back. I'll show you. I'll show you later. Okay, but I'm in the middle of something. See ya. Later. Yeah. See ya. Bye. I'll call you. Okay. Nice. Okay, so let's get back to what was I talking about again? I was talking about accelerators. Yeah. So GPUs like they many small tasks in parallel. So like AI stuff is all like when you think about neural networks, it's just a bunch of addition and a bunch of multiplication, but it all has to happen at the same time. GPU is really good at that. So GPUs are still called GPUs, but they're not for graphic processing anymore. They're not a graphic processing unit. No, it's an AI processing unit. They should rename it. So it's nothing but an ASIC. Um, bang bang. Let's talk about like maybe one more thing. Okay, so ECC is error correcting code. It's a type of memory that detects and corrects data corruption in servers for reliability. Okay, so this is how it works. It works by using a checksum. Okay, a checksum is an algorithm. Basically, I've got all these bits 101010 1, and it takes like it looks like a bunch. It looks like the last like I don't know X number of digits, and it uses the checksum algorithm to produce like a certain like special bit code sequence based on these things, and it puts it at the end. It appends it. So like let's say it produces 111. Okay, now um now like I do all my stuff with this, right? And if next time I look at this guy, right, and I look at this thing and I compute the checksum based on it again, or maybe it's not the last few digits, maybe it's the whole thing. Actually, let me think it. um I don't know if it's just the last 5 digits. It might be the whole thing, okay? Whatever. It's some the point is it's some number of bits of the original data, and then you add like this you append like a special code generated from the original data. And then next time you interact with this data, the algorithm goes again and it takes the original thing, it does a checksum algorithm, produces 111 again, and it compares it to this. Now, if the data got corrupted in transition, right, this checksum, these bits would be different. And basically, if those things are different than this, then we know that something's gone wrong. Data's gone corrupted. Error correcting code. Nice algorithm. Nice little fun little algorithm. For reliability, oh yeah, big red flag. So, what is the state of the art now? DIM. Oh, it is registered, bro. It does mean registered. RDIM, I think it means registered. Multiplex, multi-rank, I don't know. Okay, let's see this for a second. Get on here and talk shit about servers. Sounds like a plan. What I said, great idea. This is a fucking great idea. I'm gonna do this again tomorrow. Okay. Um, ECC DDR5 MRDIMMs. ECC DDR5. Maybe we can put SDRAM too. MRDIMMs. Boom. This is the current highest standard enterprise server memory, working memory, RAM stick. People just say DIMM. It's not what it is. Okay, I hate that. This is what it is. Super good. Um, yeah, I'm gonna leave it at that. 23 minutes should be more than enough. I'm gonna have a server part 2. We're gonna learn all about servers. Maybe we'll talk about Flash. Didn't get to talk about Flash. Maybe I'll spend the next 2 minutes thinking about this entire thing and how I feel about it. Basically, this feels pretty fucking good. I want to talk about autoencoders next session because I learned a lot about them. Their type of neural net, their type of a recurrent neural net, unsupervised. Wait, not recurrent. It's just a type of unsupervised. Um, they're really cool. This is gonna be unedited forever, by the way. All of these, and I'm gonna keep making them. So, and I'm gonna learn such a shitload about servers. It's gonna be insane. And I'm gonna put it all out here. And you know what? No one's watching, so it is what it is. But I just crave the chance to like talk about it because I feel like it's gonna leave me if I don't talk about it. Talking about things makes it, part of my brain. I want to keep these things a part of my brain. All this PCIe such. When I talk about this out loud, I realize I don't really know what I'm talking about. I don't really know what I'm talking about at all. I have to continually refer to my notes, and I think that there's a lot more learning for me to do, a lot more growth, a lot more mastery. Um, there's so much left, servers and networking, IT infrastructure is such a ocean of information, such an ocean. I've only just started learning about it. Um, yeah. Anyways, I'm gonna exit the stream now. Bang bang.